Hey everyone, thanks for joining us for today's webinar. This is Maddie and Pablo from Tulip, the manufacturing app platform. A little bit about where we're coming from. Tulip was started by a team of engineers out of the MIT Media Lab. Our platform is based on over 10 years of research into digital manufacturing, and we're led by experts in technologies like the Internet of Things, human-centric interaction, augmented reality, and machine learning. So today we're going to be looking at Industry 4.0, which incorporates a lot of those technologies, and examine how Industry 4.0 is transforming lean manufacturing. Our objectives today are to become more acquainted with those enabling technologies, understand what Lean 4.0 means for manufacturers beyond the buzzword, and review some Lean 4.0 use cases and how those specific applications drive efficiency and profitability for manufacturers. So first, let's look at what Industry 4.0 is. We think that the key element of each industrial revolution has been an enabling technology that drove a cultural change that yielded some sort of production change for makers and manufacturers. So earlier revolutions, that's steam power, electricity, electronics, up through the current Industry 4.0, current fourth industrial revolution. The enabling technologies we're going to examine are cyber-physical systems and the Internet of Things with relation to the introduction of the cloud to the shop floor, and how incorporating those technologies is really changing and digitizing manufacturing in the present. For lean manufacturers, this new technology is an opportunity to access the core objectives of lean manufacturing, empowering people to drive improvements on the shop floor. So let's examine these technologies further. First, let's define what cyber-physical systems are. So cyber-physical systems are the result of a closed loop of sensor-based physical process data acquisition combined with cyber data processing and autonomous actuator-based process controlling connected with the internet. So more complex definition, but put simply, the CPS, or the cyber-physical system, facilitates the connecting and collecting of data from production via a network, usually the cloud, and that data will be collected from production. In one of these cyber-physical systems, there are three methods of communication. And these are the ways in which the system collects data. So first is going to be human to machine. Second is going to be machine to machine. And the final is data acquisition and processing. So let's look further at this human to machine communication. This collection is primarily sourced from operators, usually via some sort of digital interface. The CPS can collect information via traditional data entry. Think of methods like typing into a computer or selecting an option on a tablet. Operators can also share information through more advanced technology. For example, computer vision can collect data from specific gestures that have an assigned meaning and input that data into your CPS. Because the consumer world has digitized much faster than the industrial world, the adoption curve for this type of communication is fairly low. Many of these methods for inputting information are already familiar to operators because they're common UX and UI principles. For example, if someone sees a red button, they understand that that's more of a stop or an alert button, and a green button is more of a move forward or a confirmation button. The next type of data collection method is going to be machine to machine. As you're probably aware, machine to machine data collection isn't new for manufacturers, but it has evolved with the addition of the cloud. Previously, these machines were directly connected, and often the data in one machine was pushed into another versus there being a two-way communication. And in order for them to have that, integration, it needed to be modified in the firmware. So there's a lot of proprietary machines, and it was very expensive. The move to the cloud and the addition of additional sensors has introduced more interoperability to the shop floor. And through that easier connection via the software, it's making it easier for two-way connections and more connections between sensors and different types of machines, both new and legacy machines. And the final method of collecting data is from other databases and software tools that manufacturers are already using. For example, a lot of manufacturers, most manufacturers are using some sort of ERP to manage purchases, financial planning, employees, or they use an MES to track and trace materials, or some combination of these systems. And oftentimes these systems, all times that these systems are implemented, they contain production critical data, but can be massive, siloed, and often difficult to manage or maneuver. So the CPS can push data into these systems to avoid any kind of manual entry, or pull production critical data from these systems and introduce it to other aspects of the shop floor. Ultimately, all of these data types combine to deliver a holistic and interconnected vision of production. So let's go back to lean manufacturing. The value of lean methodology for manufacturers is that it helps manufacturers reduce operational complexity, eliminate waste, and drive productivity improvements by empowering their workers on the shop floor. This human element is a key principle of lean manufacturing, because human analysis and flexibility produces the majority of the efficiency from these principles. So traditionally, when people think about the types of waste to remove, they think of the 7 wastes. The often optional 8th waste is a key waste and key area of focus when thinking about Lean 4.0 or incorporating Industry 4.0 technologies and lean methodology in a shop floor. So there are a variety of ways that manufacturers introduce lean methods and lean tactics to their shop floor. We'll consider these different methods the lean toolbox. There are different times and different processes that appeal best to specific tools in this toolbox, and it doesn't always make sense all of the time to apply all of them or any one of them to every factory. So it's not the same for everyone, but the principles themselves can be applied to drive efficiencies for most manufacturers. So looking forward towards what Lean 4.0 means for manufacturers. Industry 4.0 as the enabling technology and lean manufacturing as the cultural application of that technology is what we define Lean 4.0 as. Just looking at the value of each of these to manufacturers, just digitizing processes, shop floor digitization, for example, standardizing and digitizing work instructions can drive efficiency for manufacturers even without incorporating lean principles. Most manufacturers that have successful implementations see about a 10 to 15% improvement in their operating costs. So this is gained efficiency for these manufacturers. For manufacturers that are implementing lean manufacturing principles but not incorporating Industry 4.0 technologies, they're seeing similar efficiency. For example, manufacturers that standardize work, they can see a 10 to 15% improvement in their operational costs. The best multiplier of both of these technologies and methodologies is the combination. So manufacturers that successfully implement Lean 4.0 initiatives see 100% improvement over separately implementing Industry 4.0 or lean manufacturing, and receive as much as 40% or more savings and efficiency in their operational costs. However, there are a lot of places where applying this technology can cause failure. I'll pass it over to Pablo to go over the failure.
So this is, going back to what Maddie is saying, the concepts that we just reviewed could actually fail, and we have gathered some information, based on experience and what's been out there. Industry 4.0 can fail because a lot of the systems are rigid, are impossible to use by operators and supervisors, so they're not human centric. They're also expensive. If you want to make little changes here and there, you would have to get an expert in that matter to change a program in a PLC or whatnot. And then to maintain them, it's really, really, really expensive as well. Standardized solution is oftentimes impossible, although like you can have a very well distributed solution around your shop floor. Those rigid solutions are based on specific customizations, and then if you have a cross pollination of software between different plants, it's really hard to actually like grab one custom solution and apply it to another process which is very custom. Then the other part of Industry 4.0, which is like really overwhelming, it's all or nothing, right? So it's very it's high risk because of the expense that the company needs to go through. And this is when it's also like good to introduce what is the continuous improvement loop, right? So we go back and say, okay, well, Industry 4.0 is great, but then if you want to implement something, it's really rigid, it's really hard to customize, really expensive. So that doesn't really complement what lean mentality is, and it's basically that continuous improvement loop. It's kind of broken, right? Because you start, you deploy something on the shop floor, and then you test for a while. Then you find flaws in the system, and then you improve, and then redeploy it, and so forth, right? If you have a really rigid system, then you need an expert to change it. An expert costs, and then if that solution is not the permanent solution, then you have to call the expert again. And then you go into this loop, and you're draining money like crazy, basically. The other part of this is also, it's really hard for process engineers to embrace and to actually take ownership on the digitization of their processes. So this is a good time to actually like introduce manufacturing apps. Before Industry 4.0 is basically based on machine interactions, and it's the most important thing about Industry 4.0 is that it's basically based on processes, not based on humans. So a manufacturing app can actually turn your workflows into data collection system focused on the human, right? On your operators, on the people that are actually doing the work. You go into the continuous improvement loop better equipped because you can create and test and deploy quicker. And the process engineer owns that, right? And it's very user friendly. And then you can also embed media to provide intuitive experiences. And it's also a matter of integrating tools that the operator currently uses in the shop floor, like sensors, or maybe they use a torque gun and different tools. And at the same time, gather data from machines to give the operator the opportunity to make data-driven decisions. And then correlating all of that into data-driven dashboards and production data with a very interactive way of creating your dynamic logic in the app. It's the manufacturing apps, we have to look at it as basically a way, kind of like the apps that you have on your phone. These apps can help manufacturing workers be more productive and make less mistakes and improve faster on their process. And at the same time, improve communication between the process engineer and the operator as well, right? So basically what this graph shows you is, you have a process, then you create your app based on that process, right? And then what you want to do is basically be as adaptive as much as possible, so without being disruptive of your process. And then after you're done, you start collecting data, and then it's real-time data. So basically you have time studies for free after you create a manufacturing app that the operator will enjoy interacting with. It's not interrupting their process, and it's basically a way to collect your data, right? So you can augment the process that the operator already goes through with also IoT enabled sensors, right? Because you can, in a manufacturing app, it's not creating a nice interface, but it's also giving the operator the opportunity to see the data that they're not able to see today, and then give you data that you're not able to see today by creating a variable in a button, or by using a sensor that collects data and then bringing all those variables to your app and generating production data, which is valuable for everyone in the shop floor. Okay, so how do you adopt an app to in your operation, right? We have seen applications, and every day it's like the app development features are increasing every day, right? But it's basically like, start simple, right? You identify one pain point in your shop floor and say, okay, well, I need better work instructions, or I don't know what the root cause of my issues are. So all of these are different use cases that you have to identify, and there's always a pain point that will make yourself think about, okay, what is it that I don't have today that I actually like? I could create an easy app to collect simple data, and then start there, and then standardize as you go through. So keep it simple. Now going back to the continuous improvement loop that we saw before, right? So before we saw, okay, well, there's always the traditional way of implementing continuous improvement methodologies is I have a clipboard and I have a stopwatch, right? And I go out to my shop floor and I observe my process, and I can identify the different loopholes in my process, or wastes, right? And then you say, okay, well, this is one waste over here I can eliminate. It's a non-value added process or task. And then I can go back and say, okay, well, we need to correct this. But what that is doing is basically taking a snapshot in your process for 20 minutes, 15 minutes, or even an hour, or if you have a dedicated resource, it's only for a limited time. What a manufacturing app does is convert that time capturing methodology into a continuous real-time data feed, where you can actually use your app to integrate with your current process and then improve based on data that you're collecting every second, with every timestamp whenever you complete your production, right? So it's basically correlating real-time data and getting that real-time feedback, and saying, instead of being reactive, it's just being, okay, what happened here? You can actually go to the root cause and then say, okay, well, let's go. This is a flaw in my process. Let me change it, and then test. And once you test, you can scale it up. And if there's any change that you want to do, it's really easy using an interface, creating more material for your operators in order to scale it, right? So now, after that explanation, let's see some real world use cases from real customers using Tulip apps, right, currently. So this first one is really interesting It was a customer that really, they had I don't know if you're familiar with really manual operations, but they basically had a huge binder with more than 70 pages that every operator had to go through in order to complete one of their processes, right? So it was basically, you start your process, go to page 1, and that page 1 will tell you, okay, now go to page 20 because this is the product that you're handling, and then you would go back and forth in the binder. It will take an operator to be fully trained about almost 3 months. And what we basically did in this kitting process, we were able to standardize the visual work instructions in the kitting operation. It guides the operator through a complex process, and we were able to integrate it with a Pictolite solution. If you see on the screen a little green light underneath the work instruction screen, that's a little bin that illuminates when they get to that specific step in the process to tell the operator this is where you need to pick up the specific part to add it to your kit that you're sending to the customer. And another thing that we did in this process is basically using a camera to verify at the very end that that kit that the operator is packing has all the parts that the order claims to have. So we just reduce the amount of cognitive complexity for the operator, and using a work instruction to make that process way easier, right? So one of the advantages, basically, like, the training time went down 99%. No errors were actually registered after we implemented Tulip. And then the third part of it is basically we were able to standardize the cycle time for all the new and experienced operators. So you can have basically a very standard cycle time and expect and schedule your operators way better. Resource planning went to a better place, basically. The second use case that we're going to see is at a facility that we were able to speed up continuous improvement based on app creation and again with barcode scanners and cameras and tablets. So this is a custom manufacturer, and they have there are low volume, high mix, new process introduction every week or so. They're running really complex assemblies. All the quality processes were executed on paper, and there was no visibility into how much time the operators were taking to perform X, Y, and Z. Especially when you have high mix, it is really hard to keep track of time studies and basically make sure that everyone stands under the standardized takt time that is assigned to each operation. With Tulip, we were able to give the power to the operator with better work instructions on touchscreens to guide all the operators. The operation completion was aggregated. What that means is basically you would take 30 stations and you can aggregate all the data and know basically how much time it took to complete all the production for certain NPIs or new product introduction. And we were also able to include and overcome the paper-based quality audits or quality process forms, convert that to a Tulip form, and reduce the amount of quality issues by around 60%. Then this other use case that we're going to see is basically doing root cause analysis and do more improvement with accurate and better data, right? So what we were able to do is gave the operator power to, whenever they were rejecting the product, they were actually able to input what the reason was, escalate it, either go upstream to solve the issues with the operator that was actually upstream to their station, And this is, you got to see, this is a one-piece flow operation. And we were able to reduce the quality errors by 35%. The audit forms were also eliminated. So basically no paper in all of his work instructions. And we were able to also, this was really interesting because we were able to integrate with a homegrown system, which is part of integrating different systems to create better interfaces. And that's the mission around what a Tulip app can do. You can create an interface that uses the Tulip features plus getting data or sending data to from homegrown systems or existing MESs, existing ERPs, etc. So this is a very, all of this use cases that we saw before from this 3 customers of ours. And if you go to tulip.co, you'll see more of this use cases, and you get a little bit more of an insight of what other people are doing with Tulip. But one of the things that we don't talk about too much, and it's really, it's hitting reality, right? So I have experience implementing Tulip in many customers, and one of the things that repeats all the time is the integration of this new way of interacting or this new way of entering data with the current situation in manufacturing, right? So if you go to a manufacturing floor, there are papers everywhere. There's a dashboard that's all paper-based, printed sheet for, I don't know, cost or safety, right? So one of the greatest challenges is basically grab an existing process and do that digital transformation with the operators. What happens there? So you create flexible workers by getting them used to something that's really easy to implement, and then say, well, you create that first app, and then you go to the floor and put a tablet in front of the operator and say, like, what do you think? And you observe, and then they will use it or not use it, and then ask questions. Why don't you use it? Well, because I don't like this, it's interrupting. So then you realize that you have to make a really undisruptive process in order to convert it to or adapting it to what they're basically doing. It also enables active problem solving by improving that communication loop, because you can add in a Tulip form, you can add a text box where they can actually input, write down whatever issue they find, or give you some real-time feedback through sending you an email or a text, and improving either the process itself or the app itself. So a lot of the things that we have found also is that when you implement a manufacturing app, it pushes people to rethink about their process, because now you're gathering data and you're opening up, or there's also like we haven't mentioned the hidden factory, but with a manufacturing app, you actually start to reveal that hidden factory and find some of the wastes that you couldn't find without a way of giving the power back to the operator to let you know real time what's going on. It also enables a shared destiny, if you will. So basically, everyone's working for the same goal, and you can be more preventive instead of more reactive, because now you have data, and then you can start seeing patterns. If this operator that comes in first shift, John, to say a name, compared to Amy's way faster in the afternoon, and then you figure out that John, you grab a temperature and humidity sensor, you put it on that station, and then you track the temperature and then correlate that temperature with the cycle time in your station, and then you find out that John is slower than Amy, and you ask John, and John, what's going on? I don't know, I'm just doing my best. And then you look at the data, and then you see that in the morning is extremely cold, and then you ask John, are you cold in the morning? Yeah. And you do something to resolve that, right? Give him a jacket or close to the door or something. And then you find out that his cycle time slowly improves. And you wouldn't know that if first you didn't have the data to correlate with John's comment and say, okay, well, this cycle time, you start to see the process and you get to the root cause because you were able to correlate the cycle time with a sensor on the floor that tells you what temperatures is, the ambient temperature. So those are the things that, it might sound simple, but it is. It's just the apps are actually giving you the power to create simple ways of collecting better data, gathering comments, and gathering people's perception of each of the processes to improve and make that basically process continuously better in order to improve productivity or reduce quality defects, et cetera, et cetera.
Awesome. Well, thank you all for joining us. We want to make sure that we left a little bit of time to go over the questions that you sent in during the webinar. So we're going to start with approval workflows. So someone asked if everyone's able to update apps, wouldn't that cause like additional challenges, like if operators are making updates to the apps?
Yeah, so that's basically, I think, I understand it as like, if you're actually doing a change in the app, if it's so real time, are the operators able to see those changes? No, ToolTip also offers approval paths and versioning of apps. So basically, if you want to deploy an app, you publish it, it's out in production, the operator wouldn't see the changes until you actually republish them. And then you can also follow an approval path that engineer level 1, it's not able to publish any versions until engineering level 2 approves them. So you can also build that within the platform.
Seeming like a relating question, if everyone has access to the apps, how do you maintain security?
Okay, so you can also have permissions to view different apps. So you can assign different permissions to different users to only view, edit, or be the owner of the different apps when you're deploying in the floor. Yeah, I think that's what it actually referred to. I don't know.
Awesome. And then final question, for a small manufacturer, what is the best starter lean use case?
So yeah, that's a really, really good question. Normally what I would recommend is you probably have some sort of tribal knowledge on what is going on in your floor, what are the pain points. Is it because you don't have enough visibility to a quality process that you have in your floor? I would recommend you to, instead of giving you a recommendation, go with this use case or use it for root cause analysis or a 5S audit or use it for Pocoyoke. Take a look at what are the pain points. And following that same lean mentality is ask yourself the 5 whys. Why am I doing this? Why? Where are the wastes? And also think about, basically how would you go about in a Kaizen event to resolve an issue? It's the same process, but then it's identifying a way of how can I make this process better, either by eliminating paper or by creating better ways for my operators to input data. A lot of the things that our customers start with, they start off with a very simple use case. So keep it simple. They grab whatever process, if they have a form, and then they replace it with a manufacturing app.
Excellent. For those of you that ask more specific questions to your production lines, we'll follow up via email. Thank you everyone who joined for this webinar. We'll have a more general educational webinar coming up on digital transformation if you'd like to hear more, and have a great afternoon.